My name is Denise Becker. I'm a junior marine science major at the University of Delaware, and my project is about the effect of planting density on erosion and sedimentation after a coastal storm. In general, coastlines provide both socioeconomic and ecological importance. However, as the frequency of storms intensify with climate change, recognizing how beaches respond is necessary for restorative endeavors and for an understanding of shoreline dynamics. An important component of coastal dunes is the very first dune facing the waterline, known as the foredune. Coastal foredunes created and stabilized by beachgrass provide protection against storm surges. American beachgrass is the dominant dune-building grass in sandy beaches of the mid-Atlantic. Previous studies have suggested that the spatial density of grasses influences sedimentation and dune stability. However, dune growth and recovery after storms is not known. We investigate sedimentation and erosion during Tropical Storm Elsa at Cape Henlopen State Park by comparing sand deposition with natural and artificial plant patches shown in Figure 1. We hypothesize that during non-storm periods, dense patches will trap more sediment and therefore reduce erosion during storms. Tropical Storm Elsa affected the Cape Henlopen and Lewis area early morning on July 9th during low tide. The storm did not produce strong wind speeds, however, it caused a change in wind direction from west-southwest to south. For our field measurements, artificial plant densities were selected from field survey data, and individual mimic stems were constructed from zip ties. We made 2 treatment plots with 3 replicates each, sparse with an interplant distance of 40 centimeters and dense patches with an interplant distance of 10 centimeters. Field measurements were conducted before and after Tropical Storm Elsa using sediment erosion bars constructed in an equilateral triangle arrangement and structure for motion photogrammetry. The photogrammetry process begins with taking pictures across each plot and overlapping images to form point clouds. Dense point clouds, as shown in Figure 7, assigned with ground control points shown in Figure 9, allowed us to make digital elevation models which were further processed in MATLAB. The models were bilunarly interpolated onto a common grid, which allowed us to compare sand volume across different periods in our study. Our results show sediment erosion bar and photogrammetry workflow produce comparable trends with photogrammetry having a greater accuracy. From our data, erosion dominated during the storm, while sedimentation dominated in the period after the storm. Our study suggests stem density influences erosion because natural vegetation plots eroded the most, followed by dense patches, and then sparse patches with the least erosion. Sparse patches show both least storm erosion and greatest post-storm sand accretion. This knowledge can aid Cape Henlopen State Park with annual American beachgrass plantings in order to reduce erosion during the mid-Atlantic storm season.